So in many of these videos for section 5.2, I want to again stress the fact that the square root of -1 equals I. And if you notice, I'm writing on a post-it note because this is something that you might want to have off to the side of your computer as you're working. It's not something that you necessarily need to memorize, but I equals the square root of -1. There's also some common other i's, which are that I squared equals -1, I cubed equals -I, and I to the fourth equals 1. And I write these down because on slide 14, we need to use some of this to simplify some I terms. And if you want to know more details about this, where it came from, then set up a meeting with me because it's not hard to understand, but it is, I don't want to spend my time on the video coming up with that. So on slide 14, what we've got is simplifying I to the 32nd, I to the 25th, I to the 86th, and I to the 51st. And what happens to simplify this here is that you take the exponent of I and you divide by 4. Well, 4 times 8 is 32, and we get 0 left over. Well, I to the 32 is the same thing as I to the 0. And if you recall, back in the property of exponents or the exponent rules video, I to the 0 is 1. Well, I to the 25th. We're always dividing by 4 because if you look at that green post-it note, I to the 4th is 1. So how many times is 1 happening in here? So I to the 4 goes into 25 6 times. We get a remainder of 1. So I to the 25th is the same thing as I to the 1st. So I to the 21st is I. I to the 86, divide by 4. Well, 4 goes into 8 twice. And then we've got a 6 here. 4 goes into 6 once. The remainder, this 2 down here, I to the 86 is the same thing as I squared. And if you look at your post-it note, I squared equals -1. And then I to the 51st, again, divide by 4. 4 goes into 5 once. Then 4 goes into 11 twice. Our remainder is 3, so this is the same value as I cubed. And again, look at your green post-it note, I cubed is -I. So that was screen 14, but I want to finish with a few more examples here with regards to operations with imaginary numbers, and I'm on screen 25. And what typically happens on screen 25 is that people get confused because there's parentheses in it. Well, we don't need the parentheses. It's 5 plus 6i plus 2 plus 3i. Sorry, it's a little congested here. But what's going to happen is we're going to combine like terms. 5 plus 2 is 7. 6i plus 3i is 9i. And it's a complex number. Real number part is 7. Imaginary number part is 9i. With the subtraction here on the example on screen 27, we need to distribute. So we've got 3 plus 5i. Notice I'm not writing the parentheses anymore. Minus 2 plus 3i when we distribute. And then we combine like terms. 3 minus 2 is 1. 5i plus 3i is 8i. On screen 30, we have multiplication, and it has both of these problems on screen 30, slide 30. Almost the same. We've got x's in this one. 6x times 3 is 18x. 6x times 2x is 12x squared. We can't do anything else. There's no more like terms. But it works the same way with the i's. We distribute. 6i times 3 is 18i. 6i times 2i. 6 times 2 is 12. I times I is I squared. And then lastly here, we need to know what I squared equals. So again, I pull up my green post-it note. I squared equals -1. So this is, we'll go this way, 18i plus 12 times -1, which is 18i minus 12. And if for some reason the program marks you wrong, it may be picky about complex numbers. It has a real number part and an imaginary number part. These two values here are the same thing, but the computer might be picky and they might want it written in that format. Just want to make you aware so that if something gets marked wrong, you know how to fix it. So we've done adding, we've done subtracting, we've done multiplying. Here on 31, we're going to use FOIL to multiply, or double distributive property. So we'll start here and we get 14 plus 6i. And then we're going to multiply here. Negative 5i times positive 7 is negative 35i. Negative 5i times positive 3i is negative 15i squared. And we can simplify here. We get 14. These two terms here with the i's are like terms. And we get, it's not actually going to be a plus, it's going to be a minus. 29i. But once again, a reminder that I squared equals -1. Hence, my post-it note, I squared equals -1. And now that we've got that, this becomes 14 minus 29i plus 15. And now 14 and 15 are like terms. We end up with 29 minus 29i. Again, I wrote the real number part first and the imaginary part second because I suspect that the program will be slightly picky about that fact. So 32 here, slide 32, is this next one, and I'm going to write it down below a little bit so that I've got a little bit more space. And so it is, on slide 32, it is -2 plus the square root of -16 squared times -3 plus the square root of -4. So remember your order of operations here, which says to simplify what's inside the parentheses first. And we need to deal with the fact that we're taking the square root of a negative number. Square root of -1 is I. Square root of 16 is 4. So this becomes negative 2 plus 4i in this first parentheses. And it's still squared. You can't see it, sorry. Negative 2, we took the square root of negative 16. Square root of negative 1 is I. Square root of 16 is 4. And then I wrote it back into the problem. We need to deal with the same idea over here. Take the square root of negative 1 first. And remember, if you've got a post-it note, the square root of negative 1 is I. Square root of 4 there. Well, the square root of negative 1 is I. Square root of 4 is 2. So what's in our second parentheses is negative 3 plus 2i. But like I said, I needed some more space here to do this one. Because remember, squared means times itself. This is negative 2 plus 4i times negative 2 plus 4i times negative 3 plus 2i. And what I can recommend is that you multiply these two together first. Get an answer and then multiply by that third binomial. So we get 4 minus 8i, negative 2 times positive 4i. 4i times negative 2 is negative 8i. And 4i times 4i is 16. I squared. We just did first, outer, inner, last, or double distributive property. If we combine like terms here, we've got negative 8i and negative 8i. We add the coefficients. And then 16i squared is 16 times negative 1. Again, going back to the post-it note if you need it. I squared equals negative 1. So we get 4 minus 16i minus 16, which is negative 12 minus 16i. So we multiplied the first two together, we got an answer, and now what we need to do is we're going to take that value, negative 12 minus 16i, and we're going to multiply it by negative 3 plus 2i. So again, double distributive property, FOIL, negative 12 times 3 is positive 36. Negative 12 times 2i is negative 24i. Negative 16i times negative 3 is positive 48i. Negative 16i times 2i, negative times positive is negative. 16 times 2 is 32. I times I is I squared. And finally, we need to combine like terms. So we've got 36 plus 24i, negative 24 plus 48, type it into your calculator, type it into decimals, minus 32i squared, remembering that I squared equals negative 1. So we have 36 plus 24i plus 32. And then finally, we get, when we combine like terms, 68 plus 24i. One more problem. Sorry that this video is so long. I'm on screen 34, and it is x plus yi plus 4 plus 6i equals 7 minus 2i. And what we're going to do here is, this is really x plus yi, no parentheses, plus 4 plus 6i, no parentheses, because there's a plus right here. we can distribute that plus. If there was a minus, we'd have to distribute the minus. Equals 7 minus 2i. And what we're trying to figure out is what does x equal and what does y equal. But let's look at this. We've got x plus 4. That's the real number part. Here's the x, here's the 4. And that's going to equal 7, the real number part of this number over here. And if we subtract 4 from both sides, we get x equals 3. Do the same thing with the imaginary terms, the yi and the 6i. yi plus 6i equals negative 2i. And if we subtract 6i from both sides, we get yi equals negative 8i. And if you are very algebraic, you divide both sides by I. So the i's cancel out, and we get y equals negative 8.